Okay, today we're going to start section 3.3, graphing linear systems of inequalities. We did graph some linear inequalities in Unit 2, but this time we're going to graph more than one linear inequality and find the overlapping shaded region, which would be the solution to satisfy all the systems of inequalities. Well, let me show you an example first before we get started. If you look down here at your note worksheet, we have 4 inequalities. Each one of those inequalities has been graphed on the coordinate plane, and there was some shading going on either side of the lines, but the region that had the common solution to all 4 inequalities is right in here where it was bound in or on the sides of all these lines, and that's what we're going to try to do today. Okay, so let's go ahead and go to the other page and get started. Let's start with number 1. Here we have 2 systems of inequalities. I'm going to go ahead and graph these lines. So remember, we can either graph slope-intercept form or we could do a quick graph. These 2 inequalities are already in standard form, so I'm going to choose to make a quick graph. So looking at the first one, I want to find the x-intercept. So if I want the x-intercept, that means I want x. So I'm going to put a 0 in for y and solve for x. Now this is, we're going to treat this like an equation. So this is going to give me 2x is less than 6. But we're going to still think of it as an equation. X is less than 3. So my x-intercept when y is 0, x is 3. So there's my first point. My y-intercept, I want to have the y value when x is 0. So 2 times 0 plus 3 times y. And again, we're going to think about this as an equation even though it's an inequality. Okay, so my y-intercept when x is 0, y is 2. So I have 1, 2, 3, 0, and 0, 2 as my intercepts for my first inequality. Now if you remember, when we look at the inequality, this is just less. There is no equal below this. Therefore my line is dotted. If I had a ruler, this would probably be a little bit straighter. Sorry about that. Okay, now I need to decide which side of the line is shaded. Well, I'm going to choose my test point 0, 0, since this does not go through 0, 0, and see if it's true. If 2 times 0 plus 3 times 0, well, that's 0 plus 0, which is 0 less than 6 true? Yes, it is. So everything on this side would be shaded. Okay, so either I'm going to go ahead and shade that with light pencil or try to remember that. Let's look at the next one right here. And I'm also going to do, well, this one let's do y-intercept form, slope-intercept form. I'm going to subtract 2x from both sides. And that's going to leave me with negative 2x plus 2. Now be careful when putting inequalities in slope-intercept form, especially when you're dividing by negatives. Because if you remember, when you divide an inequality by a negative, for example, if I had negative 2x is less than 4, and if I were to divide by a negative, the inequality has to flip. So you need to remember those rules about inequalities in order to make sure you have the correct inequalities to graph the correct line. Okay, so for this inequality, my y-intercept, or my beginning point, is 2. So I'm going to start at 2. And my move is negative 2 over 1. So that's down 2 over 1, or I can do up 2, left 1. And if I look at my inequality, there is a line here, so that means my boundary line is going to be solid. Okay, I'm going to try to make this a little bit straighter than before. Okay, now let's do a test point. For this test point here, I'm going to go ahead and use the same form in standard form and pick 0, 0. So I'm going to do 2 times 0 plus 0. Is that less than or equal to 2? Well, 0 plus 0 is 0, so is 0 less than or equal to 2? Well, yes it is. So this side of the line is shaded. But now we have to compensate for that other line. And since there are systems of inequalities, they have to have the shared common shading. It can't be the total combined shading, just the part that's in common. So if you remember, on the dotted line, everything below the dotted line and everything below the solid line, well, that common area is going to be right here. Okay, now notice I didn't shade in here even though it is below the dotted line, but that would be above the solid line and we can't have that. And I wouldn't shade above here even though it's below the solid line. I have to have the solutions that are also below this dotted line. Okay, let's look at number 2. We have 3 systems of inequalities, so I should have 3 boundary lines. I'm going to go ahead and leave this in standard form. And I'm going to find intercepts. So I want x-intercept. That means I need an x value when y is 0. Well, if I put a 0 in here, then x is 5. And I want a y-intercept. That means I want a y value when x is 0. So if I put a 0 in here, y has to be 5. Okay, so for my first inequality, I have these intercepts, 5, 0, and 0, 5. And I have the equal, so that means including the line. So I'm going to have to make a straight line. I'm trying to look for a straight edge. Well, I'll try to make a straight line as best as I can. Okay, not too bad. Okay, I need to pick a test point. So I'm going to put in 0, 0, since this does not go through the origin. 0 plus 0, is that less than or equal to 5? Well, yeah, 0 is less than 5. So I would have to remember that everything here is shaded where 0, 0 is. Now I have these 2 other inequalities, but I want to graph them as equations. So I'm really graphing x equals 1. That means all x's are 1. That means y's can be every and anything. So if x equals 1, that would be right here, this vertical line. But notice there's no solid or including, or the equal part of the inequality. So this has to be a dotted line. And if I want everything greater, it has to be this side of the line. Okay, so far below this line and to the right of the dotted, we have this little piece in here. Okay, the last inequality, y is greater than -1. So I'm going to graph the line y equals -1. That means all y's are -1, but x's are anything. And since it's just greater, not including, we have this dotted line here. Okay, if we want everything greater, then everything has to be above this line and not below the line. So the common area, which is above this line, to the right of this line, and below the solid line, right in here, would be my solution to the systems of inequalities. Any point in this shaded area would satisfy all 3 systems. So for example, I'm going to pick, how about this point, this ordered pair 2, 0. So if I look at the ordered pair 2, 0, I'm going to put 2 in for x and 0 in for y. If I put it here, is 2 plus 0 less than or equal to 5? Well, yeah, that's true, so it fits. Is 2 greater than 1? Yes. Is 0 greater than -1? Yes. So this point is a solution to the system of inequalities. Anything in this shaded region would be an answer. Okay, we have time for one more. Let's look at number 3. We have 4 inequalities, and they're all in slope-intercept form. The first 2 is, and the last 2 are a horizontal or vertical line. Remember, if I see y and x, it's always going to be a diagonal. So I'm going to graph this line y equals x is -1. So my starting point's -1. My move is 1 over 1, positive. And if I look at my inequality, it is also including. So this should be a solid line. Okay, and so far I'm getting pretty lucky as far as lines not going through the origin. But if a line were to go through 0, 0, then I'd have to pick a different point on either side. But we're lucky here, so I'm going to pick 0, 0. And let's see, is 0 greater than or equal to -1? Yes, it is. So this side here would be shaded. Now I'm going to try to memorize that. Let's do this line. My starting point is 1. My slope is -1 over 1. Okay, and if I look at my inequality, it also has a solid line. So, or the equal to, which is going to be a solid line. Okay. And I'm going to choose 0, 0 as well. Is 0 less than or equal to negative 0 plus 1? Well, I know 0 can't be negative, so is 0 less than or equal to 1? Well, yeah, that's true. 0 is less than 1. So we've got two true statements here. So far, we are shading below this and above this. So the common region is going to be right here so far. And I've got to try to remember that. Or if you want to use pencil and erase the ones that don't fit anymore, you could do that. Y is greater than or equal to negative 1. That means all y's are negative 1. So that's going to be this one, solid line. Greater is going to be everything above. So now we're right in here. And then all x's are greater than or equal to negative 1. So that's going to be this one right here. And greater for this would be to the right. So, you know, we've got to keep in mind and try to keep this organized where we're shading. So I got to be above here, to the left of here, above this horizontal, and to the right. So my solution to the systems of the four inequalities is only going to be this little region right here. Okay, now, if you need to go back and rewind or revisit, please do so. That's why the videos are here. Or please come ask me a question, and I'll try to help. Thank you.